In this problem, we're going to solve for the tension. It's let's say it's a stoplight suspended by two guy wires. And in this problem, we want to solve for the tension T1 in that guy wire and T2 in this guy wire. And we have a weight of 100 newtons. Okay? Tension is a force. It's a force in a string or a wire, so it's a force. Yes, ma'am?
What question was this?
This is a question that I just made up.
Oh. Okay.
Yeah. Okay. All right. So the most obvious place to do our free body diagram is here. Take the tension about this knot. This knot, okay? Right here, this juncture. This juncture. It may not be a knot. I don't know. It's probably joined somehow, right? It's a knot or juncture. All right, so how do we solve this? When we're doing these force problems, we're going to do the sum of the forces in the x, similarly like how we did our problems in two-dimensional motion. We're going to take the x and y components, okay? So, for my sum of the forces, and now what should they equal up to? 0, because this is a body in an inertial state, right? Sum of the forces in the x are going to equal. Is there a force going this way here? No, right? If I take my origin here, right? If I take my origin here, everything to the left by convention will be negative. Everything to the right by convention will be positive. So it's going to equal to negative, right? T1 in the x cos 32. Yes?
Where did the 100 come from?
My head.
So she made up the problem.
I made up the problem.
Oh, okay.
Yeah.
I thought this was number 4.
No. I just made up the problem. Okay? T1 cos 32, right? Okay. All right, and T2, right? Negative T1 plus T2, and that would be sine 57. See that, everybody? Sine 57. And that's going to equal to what? 0, right? Okay. Sum of the forces in the y going to equal what? I'm going to use that as the negative direction. So negative 100 newtons. Okay. Plus T1 sine 32. Plus, because that's going up, right? T2 cos 57. All right. Okay.
Are we also saying that equally again?
Yes. Yes, thank you. Right, because that's not moving up or down. Okay, lovely. All right, now let's, we've got 2 equations, 2 unknowns, right? So I'm going to go with this guy. And I'm going to say T1 cos 32 equals T2 sine 57. Just pop that on over to the other side of the equation. Subtracted that from both sides. I mean, added that to both sides. Okay? All right. So what do you want to solve for? T1 equals T2 sine 57 divided by cos 32. I've got an expression for T1 now. So I'm going to go back up to here and pop that in there. And I've got T2 sine 57 over cos 32 plus T2 times cos 57 equals 100 newtons. And I'm sure somebody would be lovely and solve that for me. I'll take it, Gwen. You got it? Not yet? All right. Do you have it, Jasmine? Yes.
No, I have a question.
Yes, ma'am.
Are we missing a sine 32 in the equation?
Let's see where.
Like when you plugged in, you know how it's T1 times sine 32?
Let's see. Oh, right, wait. T1. Oh, yes, we are. Thank you. Yes. So, yes, we are missing a sine 32. So, oh, thank you for that. All right, yes, very good. So, I forgot to add this to that term. So, good. Good. I'm glad you caught that. Yeah, perfect. Thank you. Yeah. Very nice. Keep me on the straight and narrow there. Okay, anybody have that?
88.7.
So, oh, wait a minute. This should be T2, right? Yeah. T2 equals 88.7 newtons. And then I just go pop that value here. So I can do, can I erase some of this? Yeah, good. Okay, I have a T1 cos 32 equals 88.7 newtons times sine 57. Anybody have that?
$87.7.
So T1 equals 87. Okay. Very nice. All right. We can extinguish that camera. Thank you.